All right, number 6, we want to compute the critical value for Z alpha over 2 that corresponds to 89%. So just like number 5, we're going to have bell curve, and so in the middle is going to be the 89%. Now if you think about this as a decimal, if you do 1 minus 0.89, that gives us 11. So that is our alpha. So we're going to divide that by 2, and that's going to give us 0.055. Okay, so the area in this tail is going to be the same as the area in this tail. And I just need to look at one side and I can figure out what that number is. So if I look at the negative side, let me focus this. So if I look at the negative side, that'll be enough to get that point. So I'm looking for 0.055 in the middle. I'm already too far, 0.055. Maybe on this row. The closest thing, 0.054. Guess I'll go up on the next row. And that's too small. So it looks like it's increasing to here. So we got 0.0559 at the end, and then 0.0548. So this one, if you add 2 tenths, hundreds, thousands to 2/10,000, you'll get there. This one is 9 above it. So this number here is going to be closer. So negative 1 point, or just 1.60. So we're looking at 1.60 to represent that number. All right, number 7, we want to determine the point estimate, population proportion, margin of error for the following interval. So we got a lower bound and upper bound. So kind of like number 4, the distance between these two is going to be even. So given the upper and lower bound, we know the very middle. So I can add these and divide by 2, and that will tell me the middle. So we're going to add 0.257 plus 0.603, and we're going to divide by 2. So we're just finding the middle, the center point, so that's 43. So 0.43 looks like our point estimate. Now you can do the same thing, like, or similar, like you could find the distance between them and then find the error. So that's the next thing we're going to do, is find the error. I think find the margin of error. So what we want to do when we find the margin of error is find the gap between these two. You could take the 0.43 and subtract one of these, which I'll show you that as well. So if I do 0.43 and I subtract the 0.603, okay, it gives me the 1.173. You could also find the distance between these. So if I do 0.603 and I subtract, so it's kind of like finding the range. Subtract the 0.257. So I'm subtracting the upper and lower bound. This gives me 0.346. So that's the distance. Now this distance is going to be split into 2 even parts. So if I take that number and divide by 2, it gives me again the 0.173. So you can just find the distance from the middle to one side, or you can just subtract the 2 and then divide by 2, and that gives us 0.173 for our margin of error. And then the number of individuals in the sample with the specified characteristic. So if the sample is 1,000, and we're thinking that about 43% of them, we're just going to multiply the 1,000 times the proportion that we believe fit that characteristic. And that gives us about 430 out of the 1,000.